In this lesson, we're going to learn about percentiles as a measure of spread. So to begin, I'd like to go back to the previous lesson where we learned about quartiles and how we had the median being quartile 2, first quartile, second quartile, along with the lowest and the highest datum points, dividing the data set into 4 equal sections. And what I'd like to do is draw a parallel line to that to show how percentiles are related to this. So if we were to divide all of the data points out of 100 into 4 equal sections, you can appreciate that this middle point would be something called the 50th percentile, or P50, because it would be right in the center between 0 and 100. And in similar ways, if we were to divide this into quartiles, this would be called P75 and P25. So what quartiles do is they take the data range, and it's like imagining and dividing it into like a meter stick, dividing it into 100 little intervals or 100 centimeters that have an equal number of values in them. If you've ever written a math contest before, or maybe other contests, you may have gotten your result back with respect to your achievement in terms of a percentile rank rather than a mark out of something as well. And that what it does is it allows you to compare how you fared with the rest of the participants. So the equations for percentiles are a little bit funky, and be sure to add them to your summary sheet when you have a moment as well. I'm going to write them down here. They are in your note as well, and just briefly talk about what each of these interestingly labeled variables stand for. So these equations are not equations I expect you at all to memorize, but more specifically to use. They are actually rearranged versions of each other without going into the details of how we could actually make that happen. Okay? So this is the percentile rank here, PK. You can see it here and you can see it here. N with this less than sign means the number of data points that are less than a value of x, and we'll talk about that specific value of x a little bit. So they have to be less than. This is the number here with this little equal sign that are equal to the value of x, and then this is the total number of data points in the set. You can see that it's reflected in both equations too. I think one of the easiest ways to work with these equations or to learn about them is to go through the examples that we have. So in the example in your notes, we have a list of the lengths of a large litter of puppies, and their lengths maybe could be in centimeters, hopefully. If it was inches, it would be a very large breed dog, but not impossible as well. And so we have 2 puppies who have a length of 22, one with a 23, 3 that are 24, one that has a length of 25, 2 at 27, 1 at 28, 1 at 30, and then a whopper here at 33. Okay, so if we look at the total number of puppies that are in this set, we recognize that NT, or the total number of data points, is 12. And I'm going to write the word puppies after it here, just so that we recognize that 12 is counting the number of data points. It isn't reflective of the value of any of those data points. Okay. So the first question asks us, what is the percentile rank of a puppy that is 25 centimeters long? So that's this specific puppy right here. So because the question says, what is the percentile rank, we are going to use this version of the equation. Okay. So if instead we could take this range and put it from 0 to 100, what percentile ranking would this puppy have? Now you might expect, even just by looking at it, that it's more than halfway. So we would expect a percentile value greater than 50, but certainly not in the upwards of 100. So let's see how the mathematics plays out. The percentile rank of this puppy is equal to 100 times the number of puppies that are less than it. That's what the n less than symbol means. So from here, we're going to count the number of puppies that are less than, or the number of data points that are less than 25. In that case, we have 1, 2, 3, 4, 5, 6. So perhaps what I'll do here is I'm just going to put a dot under each one of these, and I'll put a 6 so that you know where that number came from. And then we're going to add a half of the number of puppies that have that data point value, in this case 25. So there is only one puppy that has that value of 25. If there was more than one, say we had chosen 24 or we had chosen 27, then this value would be a 2 instead. Okay, so how many data points are equal to 25? Divided by the total number of puppies, which is 12. So in simplifying this, we get 6 plus a half, which I can put as 6.5 over 12, multiplied through by 100. Now when you punch that into your calculator, you will get 54.2. It's not possible to have a percentile rank that's a part of a percentage. So what we do in this case is we are going to round up to the nearest whole percentage, to the nearest whole number. And the percentile rankings are always rounded up to the next whole percentage. So 54 doesn't round down to 54.2 doesn't round down to 54. It's going to round up to 55. Okay, so therefore we can say that the percentile rank at 55 is equal to a puppy that is 25 centimeters long. Okay, and that goes along with our prediction that we had before we performed the calculation. So there's part A of our example in our notes. Part B says which puppy has a percentile rank of 88. So when we're looking at these numbers, we're thinking, this is 0 to 100. 88's probably up in here somewhere, right? Okay, we would expect to get an answer in that area. So let's figure out which puppy specifically it is. Because it's asking for which puppy, which data point, this time we're going to use this equation. What is the value of the data point that is less than or equal to the 88th percentile? Okay, so let's do n less than or equal to is equal to pk. So our percentile that the question gave us that it wants to know is which puppy is at the 88th percentile. So we put 88 in there. We're going to multiply that by the total number of puppies, which is 12, and we're going to divide by 100. So when we punch all that into our calculator, we get a value of 10.56. So this is the number of the data points counting across that represent the 88th percentile, but we can't have 0.5 of a data point or counting data points. So again, we're going to round this up to the nearest whole, which is the 11th. So the 11th data point is where we would find the 88th percentile. So counting from the left, if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, the puppy that has a length of 30 centimeters is the puppy that is represented in the 88th percentile of this data set. So we can say, therefore, P88 is the 11th puppy, or we could simply say P88 is equal to 30 centimeters. And that's how percentiles work. You're either calculating a percentile for a given data point in a set, where is it if it were a similar scale from 0 to 100, or you're given a percentile and you want to know what the value of the data point is at that percentile.